So I think I can bring in my talk now. So hi, Crusoe, really happy to be here with my BOSC friends after so many years apart. I'm here to present work that was primarily not done by me. It's by our two interns, Dennis Chugunta and Dinithi Wikra Marata, as supervised also by Bruno Kinoshita. Dennis and Dinithi were co-funded by Outreachy. We'll go more into that in a second. So the topic of this talk is a converter from the WDL workflow language to the CWL open standard. And you might be asking yourself, why should we do conversion at all? Why would we care about this? There's sort of different approaches here. CWL is this community-centered open standard, which has seen adoption while we started in bioinformatics and many different fields. And WDL came from the Broad and Cromwell. Now there's an open version of it called OpenWDL, but for example, WDL 1.1 is not yet adopted by Cromwell. So conversion might help you out if you want to run your workflow in different places or take advantage of new WDL features that aren't supported by some executors. For example, the CWL ecosystem is older and bigger than the WDL ecosystem. So that could be a reason to do workflow conversion. So we started this project. I kind of sketched out the goals of it, and we found some interns that got funded. And the project goal is to take the WDL syntax and directly convert to CWL 1.2. WDL expressions are rewritten as CWL expressions. And we're targeting WDL as people actually write it. So we're not really trying to cover every little bit of the language. So we're using particular workflows to drive our conversions. So let's talk about the folks who actually did the work who sadly could not be here. So Dinithi was our first Outreachy intern working on this. So she started from nothing. We gave her the ideas and I handwrote some examples, but she put together using the Antler parser for WDL, really doing that prototyping, proof of concept, and a lot of test cases that was really helpful and got us kind of as far as we could really go with that basic approach. We realized we needed something that was more robust, especially as the WDL language has changed over the different versions, and we need to do more complex things. So she had a very successful internship. You can access these slides online and click through and read her internship wrap-up report. Our second Outreachy intern was able to take this strong foundation of having lots of tests. We love tests, and we love tests when we have to rewrite, because then you know if you're going in the right direction and what's expected of you. So he was able to move very quickly, and we rewrote the converter using the mini WDL parser and WDL executors, so many thanks to that project. And that smoothed over all of the differences from all the variations in WDL syntax, kind of Cromwell WDL, Open WDL flavors. Mini WDL solved all those problems for us and helped us really focus on doing the conversion. So Dennis was able to achieve feature parity of where we were before, and then extend it to many new constructs. So as I said, we now use the mini WDL parser. It's great. It's going to give us Python objects to represent all the pieces of the WDL file that we've loaded, and we're able to parse that and map that over using a similar library, but going the other direction that gives us CWL Python objects. We kind of map all the concepts over, and then we can serialize and output the CWL. So let's look a little bit about some of the, how does this actually work? So as we saw earlier briefly in WDL, we have the command block at the center of every command tool definition, and that's a bash script. So we explicitly make that a bash script in the CWL version, where then we represent the WDL expressions as CWL expressions. So we just generate this bash script at runtime, and then we'll execute it in the CWL version. As a more challenging conversion, WDL supports a type, it supports, of course, RAISA files, just like CWL. And if you add that plus symbol on the end in WDL, it means it can't be empty list. It has to have at least one item. A non-empty postfix quantifier. Ooh, I sound like a computer scientist now. CWL does support, of course, array of files. But currently in the official version of the standard, we don't yet have restrictions further than that, though they're being planned. But we can always work around this. So we actually do an evaluation at runtime to check the length. And if the length is not greater than 0, then we throw a little helpful exception. You can do this today in CWL, very advanced little trick. I wouldn't necessarily do this when I'm handwriting workflows, but when we're doing an automated conversion, it's really important to do your darn best. Task inputs, we likewise can convert. One tricky one is when in WDL has a very complex places. The number of places you can use expressions in WDL is more numerous than in CWL. And they have this, of course, built-in standard library of functions. And in CWL, we just use JavaScript if you need to do these sort of manipulations. So here we see that we're going to compute how much disk space is required based on the inputs. This is WDL syntax up here. And later in the WDL file, that'll be used as the resource requirements for scheduling purposes. So when we convert this into CWL, we will actually make a JavaScript version of the WDL syntax. Now, if I was writing CWL by hand, it wouldn't look like this, right? This is, again, an automated conversion. And we even support the fact that WDL has many, many different units for their memory requirements. And we just have one. So we will actually do the conversion for the user. And another example, so that was with fixed Unix, and we even have a JavaScript snippet for it if it's dynamic units. You don't actually want to write or read CWL that looks like this, but it means the conversion works and you can move forward. So I mentioned testing. Currently, we have 39 real-world WDL files plus 12 synthetic examples that are checked into our code base that are tested. We check in the CWL equivalents just to see how code changes might affect things. For many of these, we do even have end-to-end tests where we found sample input data, ran it with mini-WDL, and ran it with the converted version, and are actually checking the outputs are identical. We do more end-to-end testing, but I think if anybody who's done this, it's very difficult to find bite-sized small test data that doesn't take forever to run. A nice challenge for the whole bioinformatics community. I think testing and benchmarking is a very popular topic. So our limitations, we support simple WDL scatters. Not yet advanced ones, we're working on that. There's a lot of standard library functions in WDL that we've not yet implemented on how to convert that to CWL. We know we can, we just haven't gotten to it. And then there's some more advanced types in WDL that are not so common that we have not done the conversion for, though we have a plan. All of those limitations, though, are also driven by user needs. So if you try out a conversion and something doesn't work, please leave us an issue. We'd love to hear about that. That's very motivating, and we might prioritize that better. In addition to producing a useful tool that's going to only get better, there's been some nice side effects. So we've opened many conversations in the WDL community about clarifying their specification, and send some code up to the mini-WDL folks to improve their product as well. And even for CWL, we are looking at maybe adding some convenience features. Things have always been possible, but we can make a little bit simpler in CWL. So thanks to WDL for the inspiration. Some people may have heard the Janus pipeline system. It's pretty cool. We can write in a high-level language, and it can output workflows in different languages, and also tries to do some conversions. So we've had some people ask questions about how does what we did, which is one language to one other language, compared to Janus's goals. Unfortunately, it looks like that project hasn't been updated in a while. We did kind of get to work, but it didn't fare so well compared to our sample set. But we were really grateful for them sharing their code. We definitely looked at it and provided a lot of inspiration. Of the files that Janus was able to convert, only one of them we had an end-to-end test. And of that particular one, the test did not produce, the workflow actually failed. It was not able to produce any outputs from that conversion. So we think what we've done is more mature than what Janus has done so far. So our next steps, we just got more low-hanging fruit to work on, more test data as we mentioned, and we, of course, would love to have community contributions. You can contribute from this project, even if you don't know CWL, even if you don't know WDL. But if you know one of the other two and don't know Python, maybe you could use it to learn some Python. So as long as you get some experience in kind of one of these, you can learn about the other two. So it's a nice learning opportunity, especially if you're staying for the CoFest. So hopefully you're staying for the CoFest. We'd love to have you, and I'd love to talk with you about this project in CWL. I'll be here till midday on Saturday. So thank you very much. Thanks to our interns. No thanks to the world that made it impossible for them to be with us here today. I don't know if we're doing questions, but thank you all.
Thank you so much, Michael, for being so right on time. We have maybe for a first question.
Okay.
Yeah.
I have a question. Can I?
Yeah.
Come over here.
Oh, okay, sorry. Yeah.
That's okay. My question is actually for all of the presenters in the workflow session. So I think, we're having the joint BOSC ontologies session, and we heard from the EDM talk earlier. And I'm just wondering if you all have some thoughts or some experiences in terms of how we kind of unite some of those elements. So specifically, for example, if I want to build a workflow where I'm using ontologies to classify the inputs and outputs of various elements, how do I build those kinds of things in a standardized way to any of the workflow languages? And how do I use that for validation in order to check to see that the workflow is actually doing the things that I want? And I think there's some really great opportunities to do that fusion. So it's really for anyone who's really experienced the workflow language question.
So, do you have a WDL response?
But I mean, maybe labels.
Yeah.
We can do labels.
Yeah. So, I can give a CWL response. We're longtime friends of EDAM, and so you can use EDAM file formats in CWL. Those are checked for if they're supposed to be compatible but not equal. That is checked at runtime. We are doing provenance testing with additional with CWL Prov, which is trained this thing called our workflow running profile. But definitely there is more to be done about verifying and confirming that things match. I think also like file formats in general. Someone says, I have something that meets this. Is it really that? That's typically, Galaxy hardcodes a lot of file format checking, but it's not really available in an easy to use way. So there's a lot of, that's a great question. There's a lot for more good things there. I have to give a shout out to EDAM though, right? Because that gave the blueprint for other communities to also catch up to this. So in CWL, we support EDAM, but we didn't build it in. We said for bioinformatics, use EDAM. But for other fields, go build your own EDAM. So I think, yet again, the life sciences is kind of on the leading edge of how do we deal with complexity. So like claps to all of you for doing that.